Hello everyone, welcome to 14th session on numerical analysis of BSc 5th semester. In this session, I would like to explain you about one of the most important methods of solving the nonlinear equations, algebraic and transcendental equations, that is Newton-Raphson method. So in the previous session, what we have discussed? In the previous session, we have discussed thoroughly the different steps involved with the secant method, and we have solved one of the important examples based on the secant method. That was our previous thing. Now at the end of this session, we will be able to understand thoroughly the steps involved in the Newton-Raphson method, as well as we will be able to solve a couple of examples using this method. So let us begin with the Newton-Raphson method, what actually the Newton-Raphson method is. So Newton-Raphson method is the most advanced method in solving the algebraic and transcendental equations. So how it works, let us see. Let f of x equal to 0. Again, as usually we are going to consider, let f of x equal to 0 be the given equation, and here x naught is the initial approximation. You please look at this very important observation you have to do over here. In the earlier methods, the three methods we have discussed so far, right from bisection method, secant method and the Regla-Falsy method. In those three methods, we were having x1 and x2 or a and b as the initial approximations. We were requiring two initial approximations in those earlier methods. But here in the Newton-Raphson method, only one initial approximation is enough. We can start our work with only one initial approximation, that is x naught, and that x naught, we say that it should be in the neighborhood of the root. It should be in such a way that it is very close to the desired root. If it is chosen in such a way that it is near to the root, then the method converges faster. So that is the thing we have to observe. Now, if we have this initial approximation in hand, we can use this formula. The formula of Newton-Raphson method is here, that is this particular formula, that is xi plus 1 equals xi minus f of xi divided by f dash of xi. What is f dash of xi? It is differentiation of f with respect to x and x substituted by xi. So that we have to use here in this formula, very simple formula in fact, and this is called as Newton-Raphson formula, and we will use it repeatedly. The repeated application of this formula with the substitution of xi obtained in previous stage gives the better approximations. That is, to get x1 we use x naught, to get x2 we use x1, to get x3 we use x2. So to get the I plus 1th value of x, we use the previously iterated value of x, that is xi. So this is the iteration formula. The repeated application of this goes on giving us the improved values of the desired root, and when two successive values obtained in two consecutive steps are same up to the desired accuracy, that is up to the said number of decimal places. What it has been asked in the question, you have to look at it up to 3 decimal places, up to 4 decimal places. If you are required to find the required solution correct to 3 decimal places or 4 decimal places, you have to continue the process of iteration, and after getting the solution up to the desired accuracy, you can stop, you can terminate the process of iteration, and the value you obtain in that particular step should be taken as the required root. So this is the procedure involved in Newton-Raphson method. I hope you will definitely enjoy it, and please try to solve a couple of examples using Newton-Raphson method. The first example is, find the real positive root of the equation x to the power of 4 minus x minus 10 equal to 0, which lies between 1.5 and 2. We require only one initial approximation, but they have given two values. We have to choose one among these two. Which one we have to choose, that is very important. I will explain you now. And the solution is to be obtained up to 3 decimal places, correct to 3 decimal places, that is the question. Now let us proceed as usually. So first of all, let us take the left hand side of the given equation as f of x. This is the first step, all of you know very well. In the Newton-Raphson formula, we required f dash of x. F dash of xi is there in the denominator of the formula. Therefore, let us differentiate this. After differentiating this, you will get f dash of x. So f dash of x is this formula, that is equation number 2. So what is there? Equation 1, equation 2. So you have to be careful. Now the given function is to be taken as equation 1 and f dash is to be taken as equation number 2. So we shall use these two equations repeatedly with the new values of x in the formula to get the advanced approximations of x. Now we will find out what is the value of f at the first point, 1.5. F at 1.5, if you see, it is going to be minus 6 point something. F of 2 is plus 4. So if you please look at this small figure I am going to draw over here. For example, this is 1.5. If this is 1.5 and this is 2, at 1.5 we got, at 1.5 the value of f is minus 6.4375, whereas at 2 f value is 4. So if you look at these two values, 4 and minus 6, 4 and minus 6. If you look at this thing, again you please observe, for example, this is minus 6 and this is 4. This is 4, positive of 4. So 0 will be somewhere here. 0 will be here. After 0 we will be having 1, 2, 3 and then it is 4. So the value of f at 2 is 4 and 0 is here, and after to the left of 0 we will be having minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. You please see the value minus 6 is much far than 0 compared to 4. So we can say that 4 is closer to 0. 4 is closer to 0 than minus 6. So therefore the value 2 at which we got f of 4, f of 2 is 4, this value is closer to 0. Therefore 2 will be at the desired root. Say for example, the desired root is x. At x we are intended to find the value of f such that it is 0. So what is the root of the equation? You have to find such a value of x at which f of x becomes 0. So f of x equal to 0. So therefore we are searching such a value of x at which f becomes 0. We got f at 2 as 4, f at 1.5 as minus 6. From 0, if you observe the distance of these two, 4 is closer as compared to minus 6. Therefore, the desired root will be closer to 2, but as compared to 1.5. 1.5 will be away from the desired root as compared to 2. Therefore, this is very important explanation, you please keep in mind always. And by keeping that in mind, we choose initial approximation x0 equal to 2. The root, the value which is near to root, desired root, that should be taken as x0. So we have chosen x0 equal to 2 as the initial approximation to the desired root. So I hope you understood this explanation. With this explanation in your mind, you please use the formula, that is the Newton-Raphson formula. It is available here. By using this formula, you please observe xi as it is, f of xi, that is equation number 1, wherever x is there, xi is to be written. So in place of xi we have written, in place of f dash of x we have written f dash of xi, its value. And if you take LCM and simplify, the formula will be simplified like this. This is most important thing. No need to use this formula always. You have to you can use this simplified formula as the Newton-Raphson formula as far as this problem is concerned. As far as this example is concerned, this is now available as the ready formula, and it is in equation number 3. And we will go on substituting. We will go on substituting I equal to 0, 1, 2, 3, dot, 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 and we will be getting the improved values of x. So first, when you substitute I equal to 0 in equation number 3, that is the previously modified value, modified formula of Newton-Raphson method, that is here. Wherever I is there, if you put 0, the RHS looks like this, whereas LHS is xi plus 1, x0 plus 1 is x1. So we can substitute the value of x0, which is there, as 2. We have chosen it as 2, and if you simplify this, you will get the answer as this thing. And you proceed for the next iteration with I equal to 1, the next value. It was 0 here, now it is 1. The same equation number 3 implies x2, the new value of x, that is going to be 1.858. After simplifying this entire thing, you will get this thing. For next iteration, I equal to 2, if you substitute in equation number 3, you will get x3. x3 is 1.8556 after simplifying the right hand side. You please see, up to the 3 decimal places, the 2 answers are correct. You can stop at this moment, or else you perform on more iteration. If you perform on more iteration, you please see up to 4 decimal places, the same value you are going to get. This is the beauty of this method. Newton-Raphson method is very simple and it converges much faster. And for I equal to 3, the equation number 3 is this much. And you substitute x3 value, which we obtained here in the previous iteration. X3 value is available. You substitute that and simplify the right hand side, you will get the answer as this thing. So what you are observing? You are observing that up to 4 places of decimal, the 2 values are same. That is x3 and x4 are same up to the 4 decimal places. Up to the 4 decimal places, x3 and x4 are same. Hence you can say that the value obtained at this step, that is 1.8556, if you round it off to 3 places, so this is greater than 5, therefore you add 1 to this, this becomes 856. 1.856 is the approximate value, which is the better value of the desired root. So I hope you understood very well. So this completes the problem solution, and with this let me stop in this session. We will work out more examples in the next session. So once again, I request you people to try to solve one more example as an assignment problem. I have an example over here for you to work out. Please try to solve this using Newton-Raphson method. Find the real root of x to the power of 4 plus 4 sin x equal to 0. This is 0. Correct to 3 decimal places. So here f of x is this thing, and x0 is not been given in this problem. It is your duty to check it out. You please look at the inspection method and try to get the value of x0, and then use the Newton-Raphson formula, get the value of x. In few iterations it will converge, and the final answer is going to be minus 1.934. So this value you can get very easily If you have any doubt, please once again I request you people to look my book. This is the reference book for you. You please look at this book and try to solve more and more examples. Thank you very much.